Hey, I'm Nick Devon.
Corbin Chamberlain.
I'm Max Kingstone, and we are Team Sputnik.
The goal of this project was to design and build a vehicle with minimum drag.
The drag of the model will be measured at several different flow velocities in a wind tunnel.
There were 10 requirements and specifications that the vehicle model had to meet.
The minimum number of wheels is 4. The wheels and axle must be free to rotate. The minimum ground clearance, so the bottom of the cabin to the road, is 10 millimeters. The cabin outside dimensions and wheel spacing is shown here. The vehicle walls should be solid, so the walls should be non-porous, and if the model has any windows, they should be closed. The vehicle body length is 15 centimeters, bumper to bumper. The total vehicle weight is 50 grams. That's including the wheels, axles, and everything else. The minimum load capacity is 1,000 grams. This is when the weight is placed halfway between the front and rear axles. Vehicle body contains a circular, flat, horizontal loading surface, a diameter of which is about 10 millimeters, on the top of the vehicle and halfway between axles to allow applying of the 1,000 gram load. This area does not need to be recessed. Vehicle body contains a connector, a max diameter of about 1.5 millimeters, installed at the front end of the vehicle. The connector material is chosen by the student. This connector should easily and securely attach to the drag sensor hook located close to the floor of the wind tunnel. The connector needs to be at the same approximate vertical level as the drag sensor hook.
At first, our team was inspired by the geometry of an airfoil to make our design as aerodynamic as possible. However, we soon learned that a proportional scale of an actual airfoil was not a feasible option given the limitations of the dimensions set by the requirements. We did want to keep the smooth curvature of the airfoil in our design, so we simply increased the height of the car so that it could meet the requirements.
Initially, we chose to create our model out of foam with the intention of recreating our design in a different medium once it was finalized. However, we chose to keep the foam model in order to allow us to constantly modify our design based on our needs. Our current design is modeled after a bullet train. However, we decided to make our design more parabolic with the intention of further minimizing the drag.
We continued to refine our model by smoothing out the sharp edges and making the car symmetrical to avoid uneven airflow. By doing the experiment, we learned about drag and how it's influenced by the shape of the body. For example, our model was larger and less aerodynamic than the provided TA model. This was shown by the readings for drag, with our group's drag being almost 4 times as much as the TA model. One possible scenario in which the knowledge we learned can be applied is in vehicle design. When engineers and designers work to create a new car, compromises must be made to create a vehicle that minimizes drag while also remaining appealing to the buyer.